Hey everyone, in this video, we are building an NFT with on-chain metadata. This is a really cool thing because for most NFTs out there, the metadata is stored in some kind of hosting service provider. This metadata is the file that makes your NFT what it is. It is the file that brings your NFT to life. It's the audio, the image, the video, the text. It's this media file that defines your NFT. And if for whatever reason that hosting service provider were to disappear, let's say their servers crash, they go out of business, they've got a monthly fee which you either forget to pay or becomes too expensive, but for whatever reason they go out of business or you can no longer access that file that is stored on their servers, what are you going to do? Your NFT is going to have effectively been destroyed because that file will have disappeared. One way around these issues is to store metadata for NFTs on-chain in smart contracts. This is a really powerful concept that was popularized by a number of NFT projects. One of the most popular projects was the Loot NFT project. Let's take a quick look at what one of those NFTs look like because we are going to be building a spin-off of the Loot NFT project. Currently, 71.4% of people who watch our Web3 videos have not subscribed to the channel. So if you've taken away any value from what we're doing, can I ask just one small favor? Hit that subscribe button and join the 29%. Each week we are going to be airdropping a very special and rare thirdweb NFT to 10 subscribers. You can see this NFT here. It is a Loot NFT, a random one that I found on OpenSea, and it is just a list of words. It's a black background, white text, and this list of words are all items which can be used in some kind of an adventure. We're going to build something that looks similar but different to this. It's going to be similar in that it's also a list of words, but instead of being items which can be used in an adventure, it is going to be blockchain and Web3 related words. So we're going to have here blockchains or networks like Ethereum and Solana. We're going to have decentralized applications like Uniswap and Aave. And then finally, we are going to have tokens, cryptocurrencies like ETH, Sol, and Matic. We are only going to have 3 words instead of the 8 that are on this NFT. To build out these NFTs, we're going to use the thirdweb CLI and ContractKit to create a smart contract. We're going to build off of the ERC 721 base. I'll show you exactly what I mean in a second. And then we're going to add our functionality into that smart contract. Once our contract is ready, we will use thirdweb deploy to deploy the smart contract to the Mumbai testnet. And once it is deployed, we can claim an NFT and then view that NFT on OpenSea. It's a really cool project and I can't wait to get started. In the terminal, in my VS Code here, the first thing I'm going to do to create a new project is going to use the thirdweb CLI. So npx thirdweb at latest create -- contract, hit enter and let it kind of work its magic. We're going to have to fill in the name. Yeah, here we go. We have to fill in the name. So let's call it NFT -onchain. We have to select the framework, which is Hardhat, and then we can choose which contract we want to use as our base, the contract that we want to start working from. We've got the choice of between an empty contract, one of the NFT standards, or an ERC20 contract. And for our purposes, for this project, we need the ERC 721 contract. Then we can choose from a list of extensions. We don't need any extensions for this project, so we can select none. And then we can let it build the project out for us. This kind of scaffolds and builds out all the little pieces that we need to be in place so that we don't have to worry about any of the setup. We can just get straight into writing code, straight into building. You can see in the project that's being built out that it is installing for us the thirdweb contracts package, which if you aren't following along step by step with us and you're kind of integrating this into an existing project, then you should install this dependency so that you can use the thirdweb contracts in your project as well. And of course, Hardhat is installed here, and we're going to have to install one other thing as well, which is OpenZeppelin and OpenZeppelin's contracts. So to do that, we're going to stay in the terminal. We're going to do yarn add, and we're going to paste in the OpenZeppelin contracts package name, which I just need to copy and paste into there. Let's go copy that, paste into here, and now we can let that install. Once this is installed, there we go. We're going to now open this up in a slightly easier way for me to work with and close this. Don't know what this is. And in our contract.sol, you can see that we have imported the thirdweb ERC 721 base, and our contract is currently inheriting from this base. And of course, in the constructor, we take in and we use all the metadata for that ERC contract. And below that is where we can get started with our functionality that we'll need for this on-chain NFT. Let's write out a few comments for kind of what we're going to do in this smart contract. The first thing we're going to do is we're going to create 3 string arrays, and we're going to have one for blockchains, one for decentralized applications, and one for tokens. And remember, these arrays are going to just be lists of words which are going to be used to build out our final list of words. So we're going to have one string array that is going to be all the blockchains, and that will give us our first word. The second one will be for decentralized applications. That will give us our second word. The third one for tokens will give us our third word. And we need a way of randomly selecting one word from each of these arrays. So to do that, we're going to create 2 functions. We're going to have a random function, which will generate a random number. And we're also going to need a pluck function, which is based off of the Loot NFT project. And this will pluck a random item from the array. And these 2 functions work together. This pluck function will call the random function to get a random number, and we'll use that random number to pluck the item from the array. Once we've got that, once we've selected our random words from the arrays, we need to actually build the token URI. So this is going to be the token URI function, and this function overrides an existing function which we have inherited from the ERC 721 base. And in this function, we are going to build an SVG image which will include the random words. So it will have the random words inside the image, and that's how we will get our list of words that will have the blockchain, DApp, and token. And finally, actually we've got 2 more steps. We're going to need 3 helper functions, and these will just be to easily get the random words. You'll see what I mean by that when we get to writing it. And the final function that we're going to need is a claim function to actually claim and mint the NFT. Okay, so these are the steps that we're going to do, 6 things. It's not really complicated, it's very straightforward, and it's a really cool little project for us to work on. Let's dive into the code. The first string array that we're going to have is going to be blockchains. So let's string array, it can be a public variable, and we're going to call it blockchains. We're going to set it equal to an array, and inside that array, we're going to add in a whole bunch of different blockchains. Solana, and Arbitrum, and Optimism, and Polygon. We can do the same for dApps. We can use here Aave, Compound, Uniswap, MakerDAO, and ENS. And finally, we can do the exact same structure for tokens. And we can just use what GitHub Copilot is suggesting for us, which is ETH, DAI, USDC, USDT, and wrapped Bitcoin. We've now got our 3 arrays, which have got all of our blockchains, dApps, and tokens. Let's write the random function. So function random, this function is going to take in a string, and then it is going to, let's start by just taking that in, string memory, okay, input, and it is going to be an internal pure function, and it is going to return a uint 256. And inside the function, we're going to cast the hash of that input, of that string input, into a uint 256, and we can then return that. And that will give us a random number based off of the string, obviously. And this function, this random function, is going to be called in the pluck function, which we are about to write. So let's start that. Function pluck. This is going to take 3 arguments. The first is a uint 256, which is the token ID. The second one is going to be a string memory, and this is going to be the key prefix. This is used for the randomization. And the last one is going to be a string array, and this is also going to be in memory, and this is going to be the source array. This function is going to be an internal function. It is going to be a pure function, and it will return a string also in memory. And then inside the function, we have to declare a new variable, a uint256. This is going to be our random number. We're going to set it equal to the random function. So we're going to call the random function. And into here, we're going to pass a string that is from the input that we have provided to the function. So .encode packed. And in there, we need to pass in the key prefix, and then strings.toString, which I will explain in a second. We're going to pass into there the token ID and finish that off with a semicolon. And once we've got that, this is our random number. Once we've got our random number, we can then use that random number to get our output, which is going to be from the source array. We're going to use the random number to get a random item from the source array. And then finally, we need to return the output. And now that we've got these two items in place, let's see what our error is. Internal, this is misspelt, internal. Great. Now that we've got that in place, we can just quickly explain where this comes from. So this strings.toString is actually being imported from the OpenZeppelin strings library, which, if you remember, we imported OpenZeppelin contracts at the very beginning, and now we need to just paste into here the import for the strings library. So I'm going to just copy that and paste it up here. Click save, and then you can see that. Why is that still giving me an error? Okay, let's just close this because sometimes it forgets that it actually is imported. There we go. Oh no, still giving me an error. Let's try installing it again and see what happens. And then close this. Okay, that seems to have worked. For some reason it didn't install properly before, but it is now installed, and so we can use the strings library to handle our strings. And so we convert this token ID into a string, pass it in, and then we can generate our random number. So now that we can select a random word from each of these arrays, we need to build out the token URI function. This function, as we mentioned before, overrides the existing or the inherited function from the ERC721 base. And so it is structured like this. We've got function token URI, and it takes in a uint256, which is the token ID. It is a public function. It is a view function, and it overrides. It will return a string in memory. And then inside this function, we're going to declare a new array. We're going to declare a new array. And then we're going to set each of these parts to a different piece of the SVG that we are building. I'm going to copy this in. I'm going to copy and paste it in, and you will be able to find the full source code for this in the description of the video. You'll find a link to the GitHub repo and to the guide that will help you along with this. But I'm copying in here each of these parts, which make up the SVG file, and you can notice a few things here. Firstly, we're using the SVG tag, so you can see opens and closes. Each of these items that we are getting over here, these are the three helper functions that are our next step that we have to write down here once we've finished with this function. So we're okay with these errors for now. And once we've got all of these parts in place, we need to combine them into one string. So to do that, we create a new variable, a string. We can call it output, and we're going to make it equal to a string of the abi.encode packed, and we're going to pass into here each of these parts. So we're going to pass into here parts at position 0 and all the way through 0, 1, 2, 3, 4, 5, 6, and 7. And then we need to close that or delete that. and we need to delete that also. And now we are ready to keep going. So we've passed into here the string, we've passed in all of the different parts, and this will combine our string into one big string, or this will combine each of the parts of the array into one big string. The final step in this function is to build the JSON, which is the actual URI of the token. So string memory JSON is going to be equal to base 64, and this is going to, I'm going to copy and paste this in here also because it is a little bit complicated and it'll be much easier to avoid any typos along the way. There we go, can paste this part in here also. And a few things to notice here. Firstly, this base 64 is also imported from an Open Zeppelin library, so we need to copy and paste in that import as well. So we need to go up here and paste that in there. And this strings.toString actually needs to come from the Open Zeppelin library. This token ID needs to be underscore token ID. And what we are doing here is we are creating the base 64 version of this string, which is going to have all of the details that we have built above inside it. So once we've got that, we are ready to return it in the correct format. So we add in this data application /JSON semicolon base 64, and then we've got the URI, the token URI, ready to go. The next step that we have to do is to fill in these three helper functions. So we need a function called getBlockchain. And this function is going to take in a UN256 token ID, public view function. It returns a string memory, and it calls the pluck function, passes in the token ID, the word blockchain, and the blockchains array. And then that is the random word, the random blockchain, or that we need inside the token URI function. Sorry, just correcting this little error here. Each of these needs to actually be underscore token ID. And you can see now the get blockchain function now exists and it's returning what we needed to, so that error has disappeared. And so we're going to add the get dapp and the get token functions as well, and they're going to be exactly the same as the get blockchain. So function get dapp is going to be exactly the same, except it's going to be passing in the dapps array and the word dapp over there. And finally, the function for get token is going to follow the exact same pattern as well, underscore token ID. It's going to be a public, let's try that again, public view function, and it is going to return also a string in memory, and inside of it we're going to return the pluck function, passing in the token ID, token, and the tokens array. So now that we've done that, we've got all of the pieces in place to actually build the token URI. Just to go over again what we've done, we've got the arrays with each of our words in it. We've got a random function to give us a random number, and we use that random number to select an item from each of the arrays. Inside the token URI function, we build out this SVG that calls the get blockchain, get dapp, and get token functions to get the random words for each of those, and then it formats it in the correct way and returns that output at the very end of the function. These are our helper functions, and the final step that we need to do before we can actually deploy this smart contract is the claim function. So the claim function is going to be a really straightforward function. Claim, function claim, it is going to take in a UN256, but this is going to be an amount. So this is the number of NFTs that you want to claim. This is going to be a public function, and inside this function we're going to require that the amount is more than 0, and that the amount is less than 6. And then we're going to call the safemint function, which is inherited from the ERC721 base. And we're going to pass into there two arguments. The first is the wallet address that we want to that we are minting to, and the second is the amount, the number of NFTs that we are minting, and there we're passing in the message.sender, the wallet that initiated this transaction, and the number of NFTs, the amount that was passed into this function. And now we've got all of the pieces in place to actually build out the NFT's token URI and to claim an NFT. And the next step that we can do is deploy this smart contract to the blockchain. To do that, we're going to go here, npx thirdweb at latest deploy, hit enter, and the thirdweb CLI is an unbelievable tool for deploying a smart contract, because we can deploy the smart contract without running the risk of exposing our private keys. So you can see here that it is detecting the project type, it's compiling the project, processing the contract, right? This is the name of the contract that we've got here. It's pinning the data to IPFS, and then it will give us a link and redirect us to the browser where we can deploy the smart contract from within the thirdweb browser, or within the thirdweb dashboard inside your browser. This is really, really cool. And it is much safer than doing this through some kind of complicated config files and managing private keys in environment variables or anything similar to that. So we can see here that this has been automatically redirected to the thirdweb dashboard. If for whatever reason you weren't redirected, you will see in your terminal that there's this link here which is generated at the end, and that will take you to exactly the same place, straight into the dashboard. So it has detected these different extensions that we are building with, and to deploy the smart contract, we need to pass in these parameters. So if you remember, these parameters come from our constructor. Let's just close the terminal 1 second. These parameters come from the constructor. So the thirdweb dashboard sees what is required by the constructor and gives us the space to fill that in. So let's call this OnChain dash NFT. Let's give the simple OnChain, right, OC. Let's create the royalty recipient, and let's see the royalty basis points at 100. We can select the network that we want to deploy to. I'm going to deploy to the Mumbai Matic, the testnet, and going to click on deploy now. There will be 2 MetaMask transactions that should pop up. Let's click on confirm, wait for that transaction to be mined and to be processed, and then we will be able to approve the second transaction, and that should pop up in a couple of seconds. Let's just give that a few seconds just to come up, and waiting for it. There we go. Here's the second transaction. We can confirm that, and this transaction will process, and then the contract will be deployed. Once the contract is deployed, you'll see that we'll be redirected to the dashboard for this contract, which is a really nice place to manage the smart contract that has been deployed. You'll be able to see there all the different tabs and all the different things that we can do with the contract, and it's busy loading. Okay, great. So it's been deployed, and now we can see this dashboard. So a few things to notice here. Firstly, you can see that this is the name that we gave it, right? The OnChain NFT name. This is the address of the smart contract. This is the contract explorer. So this gives us the ability to actually interact with the contract that has been deployed. These are the write functions, the read functions. We can call any of these functions from right here in the dashboard, and it is a really powerful feature. The events tab is where we can view events that have been emitted by the contract. So when the contract was deployed, this is the event that was emitted. The NFTs tab is where we can manage all of the NFTs. Because thirdweb detected that this project or this contract is using the NFTs extension, it gives us the ability to manage the NFTs from within the dashboard. So we can mint NFTs here, and we'll do that in a second. The code tab is by far my favorite tab. This is the place where you can come to get little code snippets to build with the contract using thirdweb's SDKs. So it gives us React snippets, it gives us JavaScript, Python, and Go snippets, and also thirdweb's Web3 button. This Web3 button is the easiest way to actually call a contract from within a React application. And you can see just how simple it is. You can call any function that the contract has on it. You can read data, you can write data, and all of these code snippets are here waiting for you to build with them. Let's go over to the NFTs tab and actually claim an NFT. We're going to click on the mint button. We're going to pass in a name. Let's call it NFT0. We're not going to pass in any media because that should be generated for us. And then we're going to click on the mint NFT. One transaction should be triggered and the MetaMask transaction should pop up any second. We're going to click on confirm. And remember, the reason why we didn't pass in any media over here and we only passed in a name is because our contract is meant to generate that media inside the contract and store it inside the contract. Again, this is the beauty of storing the metadata on chain. It's a really powerful feature, this. Once the contract is minted, we'll be able to see it in the dashboard and then we'll be able to view it in OpenSea as well, hopefully. Great, so that's done. You can see that this is the NFT that was created. Let's click on it. We can't really see the picture, but we'll zoom in on that in a second. But you can see the details of it. You can see the token ID is 0. The token owner is my wallet. It's an ERC721 token. And we've got the option to transfer it or to burn it from in here in the dashboard. And this would work for as many NFTs as we want to mint from this contract. In the Explorer, we could do similar things as well. We could also call the claim function, pass in a number over here. We can call the mint2 function if we wanted to. We can check the balance of. So let's actually do that. Let's pass into here my wallet address, paste that into there, click run. And let's see if this will work for us here in the dashboard. It tells me that I've got one NFT from this NFT project that is in my wallet. And again, this is just a really cool feature. thirdweb allows you to interact with the contract once it's been deployed on chain. Let's take a look at OpenSea and see if we can see the NFT that we claimed in the profile. So I'm on testnets.opensea in my account over here, and I don't see it. Sometimes with OpenSea, it takes a little bit of time for it to actually be like indexed and reflected appropriately. So this may not show up here right now, but I just want to make sure, yeah, this is the correct account. So maybe it'll show up shortly. But for now, we can't see this NFT on OpenSea. Let's just double check that I'm in the right account. Yeah, this is the right account and I'm in the profile. Oh, there we go. It loaded. So now it just needed a little bit of time, but now we can actually see this NFT that we've got here. So it came from the OnChain NFT contract. This is the this you can see over here is the description of the NFT, and the name and the description is the Web3 card, and it gives the token ID, the description, OnChain NFTs created with thirdweb, and you can see that all in OpenSea. It's a really, really cool little project. Of course, this has got a pink background, not a black background, but there's Solana, Uniswap, and DAI. Those are the blockchain, the DApp, and the token that we got randomly generated for us, and that is an NFT with on-chain metadata. If you have enjoyed this video, please like the video, subscribe to the YouTube channel, and hop into the thirdweb Discord. The whole thirdweb team is there waiting for you. If you've got any questions or anything that you want to discuss, it is the best place to be. Thanks for watching the video, and we can't wait for the next one.